Thank you for the opportunity given. This time I will explain about minimum spanning trees. Introduction. Graphs are an important tool in the fields of electrical engineering and information technology, especially in minimum spanning tree search problems. Graphs are used for routing, which involves creating routes or paths with specific goals, such as finding the path with the lowest cost, fastest travel time, shortest distance, or highest efficiency. In various fields, graphs help achieve work efficiency and optimal results. The concept of trees in graph theory is very important because of its wide applications, such as in family hierarchies, organizational structures, and tournaments. Previous research has studied many algorithms for determining minimum spanning trees on weighted graphs, such as research by Glure et al. 1993, Greenberg 1998, and Papanzelina 2004. This research aims to test the PRIM algorithm in determining the minimum spanning tree on weighted graphs and evaluate its computing time. It is hoped that the research results can increase academic insight into graph algorithms and provide practical input in designing weighted graph models. The problem formulation in this research is how the PRIM algorithm is applied to weighted graphs and how the auxiliary program created is able to model graphs and calculate distance/length using the PRIM algorithm. An algorithm is a description of the logistical steps to solve a problem, written in special notation so that it is easy to understand and translated into programming language syntax. Zaccaria and Prihono, 2006. Algorithms are a part of computer science that focuses on problem-solving procedures. A good algorithm allows a computer to complete calculations quickly and accurately, while a bad algorithm can result in slow or imprecise solutions. Algorithms require input to start and produce certain outputs. To find the right algorithm, you need to pay attention to several things. 1. Type of problem to be resolved. 2. Basic idea of the algorithm. 3. Time required to resolve the problem. 4. The amount of data that can be handled by the algorithm. The graph G is defined as a pair of sets, V, E, written with the notation G equals V, E. In this case, V is a non-empty set of vertices, knots or vertices, depicted in dots, and E is a set of edges, edges or arcs, depicted in lines connecting several nodes. Munir, 2009. It can be said that a graph is a collection of vertices connected by edges. A weighted graph is a graph where each edge is assigned a value. The weights on each edge can vary depending on the problem being modeled with the graph. Weight can express the distance between two electricity poles, capacity, travel costs between two cities, message travel time from one communication node to another communication node, production costs, and so on. Adjacency matrix is a general representation of a graph. This matrix is nxn for a graph G with n vertices, called A equals age, where age equals 1 if vertices I and j are neighbors, and age equals 0 if not. Zaccaria and Prihono, 2006. The number of elements in the adjacency matrix is n superscript 2, with memory requirements Pn superscript 2 if each element requires P space. The advantage of using an adjacency matrix is the ease of direct access via an index to determine whether two vertices are neighbors. For a weighted graph, age reflects the weight of each edge connecting vertices I and j. If G is a weighted graph, the weight of the spanning tree T of G is the sum of the weights of all edges in T. A spanning tree with a minimum weight is called a minimum spanning tree and has many applications in real problems. Munir, 2009. In a complex graph with several alternative visits between vertices, finding the best alternative can be done by finding the shortest distance between vertices. The steps to calculate the minimum total distance of a graph are as follows. 1. From the graph formed, pay attention to whether it meets the criteria for a spanning tree. 2. Perform tracking sequentially starting from the first node to the last node. 3. At each node, pay attention to the value, weight, of each side. 4. Take the smallest value, meaning the shortest distance from each side of the node. 5. Continue until all the nodes are drawn in the spanning tree. 6. Add up the selected values or the minimum distance connecting the nodes. Applications. The data obtained regarding the distance or length connecting points or vertices is entered into the system to obtain a weighted graph model. These points are connected with lines according to their respective distances, which then form a weighted graph using the Delphi 7 program. Then it is processed using the PRIM algorithm method to get results in the form of a minimum spanning tree, a sequence of minimum spanning trees, and the computing time in searching for the minimum spanning tree. The entire stages of the PRIM algorithm process in finding the minimum spanning tree. Discussions. This research uses a program created with Delphi 7, a Pascal-based programming language that operates in the Windows environment. Delphi utilizes rapid application development (R80) techniques, which simplify the programming process. Madcoms, 2003. Apart from that, Delphi applies the object-oriented programming (OOP) method. Implementation of the PRIM algorithm to determine the minimum spanning tree on a weighted graph with Delphi 7 includes several stages. This process produces a minimum spanning tree sequence, minimum total length, computing time, and a graph of the PRIM algorithm test results. System testing. The following test example is an attempt to prove the application of the PRIM algorithm in determining the minimum spanning tree from a weighted graph model with 80 vertices and 228 edges. The minimum spanning tree formed from the results of the PRIM algorithm processing the weighted graph model above can be seen in Figure 10. The test results show a sequence of minimum spanning trees with a total minimum length of 10,958.1 and a computing time of 2.765 seconds. Tests were carried out with a weighted graph model which had variations in the number of points/nodes and number of edges. The tests in this research were carried out in order to obtain accurate computing time to determine the performance of the PRIM algorithm application. The Delphi 7 program is used to apply the PRIM algorithm to find the minimum spanning tree on a weighted graph. This program has the following capabilities: displays a weighted graph with distance as the weight connecting the points, minimum spanning tree visualization using PRIM's algorithm, store weighted graph models and minimum spanning tree results visually, displays an adjacency matrix containing the distance between points, displays minimum spanning tree sequence information, minimum total length, and computation time. Displays graphs of PRIM algorithm computing time test. Results. Implementation of the PRIM algorithm application system using Delphi 7 involves 1. Use of 10 module units to implement the PRIM algorithm, such as global, map, MDI_map, method PRIM, properties, output visual, save, open, delete, and result PRIM. 2. Use of 9 form models, including map, MDI_map, method PRIM, properties, output visual, save, delete, open, and product PRIM forms. 3. The PRIM algorithm process uses array and record data structures to store information about connected nodes, the relationship status of nodes in the minimum spanning tree, the distance between nodes, and the results of the PRIM algorithm. The final results are stored in the database table used by the system. Conclusion. From the series of tests and analyses in this research, the following can be concluded. 1. The program that has been developed is able to implement PRIM's algorithm successfully in determining the minimum spanning tree. The application process is carried out by forming a weighted graph, then looking for the minimum spanning tree using the PRIM algorithm. The result is information about the total minimum distance connecting all points or nodes, as well as the computing time required to find the minimum spanning tree. 2. Testing shows that the Delphi 7 program is able to apply the PRIM algorithm effectively to find the minimum spanning tree.